Okay, let's examine the given graph, and we're going to use limits to show that this point actually exists. I'm just going to erase this. So first let's state the domain of this function. Well, this is a polynomial function. It's an odd degree polynomial. You can see that the degree here is 3. So the domain here, x belongs to the set of all real numbers. There is no restriction on x, and the range here, y belongs to a series of all real numbers. Okay. So let's evaluate the following. Here we have some limit applications. So let's start with part 1. Limit as x approaches -2 from the left side of -x cubed plus 4x, right? So when we're looking at -2 from the left side, this is equivalent to a value that's really close to 2, that's approaching the left side. This could be like -2.000001, right? And if you're approaching -2 from the left side, you're basically going this way on -2, and you can see that it gets closer and closer to the x-axis, which basically means that y is 0, right? So the limit, and we can imagine that f of x here is -x cubed plus 4x. So I'm going to rewrite this as limit as x approaches -2 from the left side, f of x, or y, which is this portion here, becomes 0, right? It gets closer and closer to 0. Right, let's take a look at part 2. X is approaching -2 from the right side. Well, we know that the right side of -2 is equivalent to a value that is really small and approaching -2 from the right. This could be like -1.99999, right? And in this case, as limit x approaches -2 from the right side, f of x, or y, will approach, and you can actually kind of see this if you draw this out. See a different color. Right, so if I approach -2 from the right side, we're going this way, and it gets closer and closer to 0. So this also equals 0, right? Now, for part 3 here, we can see here that limit as x approaches -2 of f of x, and this is the original limit, right? And we can utilize the limit property, and the limit property in question we're going to be using, limit as x approaches a of f of x should be equal to f of a, and it should be equal to L. And this is L should be a finite value, right? If f of a doesn't exist, then this limit itself doesn't exist and the point doesn't exist, okay? So in this case, limit as x approaches -2 of f of x is equal to f of -2. And f of -2 here, if you look at your graph, it's equal to 0. Okay, so the original limit is equal to 0, right? And part 4 here, I'm going to use a different color for that. Part 4 here is asking us what f of -2 is. So f of -2, if you plug it into, and we said that f of x is -x cubed plus 4x, it's basically -2 cubed plus 4 times -2, which is basically equal to 8 minus 8, which is 0. Right? So f of -2 is equal to 0. And this tells us that the point actually does exist. So if we wanted to do part C, is the graph continuous at x is equal to -2? Well, one of the reasons that they asked you to kind of figure out all of these pieces of the limit is to actually show the proof to show that x is equal to -2 is continuous. We can see here that, therefore, the limit as x approaches -2 from the left side of f of x is equal to the limit as x approaches -2 from the right side of f of x. So our left-hand limit and our right-hand limit are the same. So that's one of the criteria that have to be met to show that a point is continuous. The other criteria is that the point of the original limit, x approaches -2 of f of x, should be equal to f of -2, which is equal to 0. So because all of these points are equal to 0, therefore x is equal to -2 is continuous. So this is like the statement, your final statement that proves that the point itself is continuous, and all of these limit criteria have to be met.